quite a while now, I've wanted a Roman sword. I have a charcoal forge, but I'm inexperienced. It's not a great setup anyway. And this is America, so I wanted my sword now, with free refills and 2-day shipping. So I decided to do this the easy way, and grind one out of flat bar. After looking around for an example with decent dimensional data, I scaled up the line drawings from 2 sources and printed them out actual size. To plot out the sword profile, I made lines across the drawings every 10 centimeters and set my calipers to what felt like an average of the 2 widths. Then I could measure this, divide it in half, and transfer to a folded piece of paper at the corresponding location. I added a fudge factor of 1.5 millimeters to account for the original edge rusting away. Once all the widths were marked out, I sketched them together and cut out my pattern. By the looks of it, this is way more symmetrical than the original. Then I traced it onto my 5/16 or 8mm stock and cut it out with the little angle grinder. This sword type is known to archaeologists as the Gladius Hispaniensis, or Spanish sword, as the Romans themselves believed the design was Spanish in origin. Our example comes from Šmihel, Slovenia, dated to about 170 BC. I'm going to avoid trying to pronounce that again. With most of the scrap cut away, I used a heavy angle grinder to refine the profile. The belt sander helped smooth out the curves and take burrs off the edges. If the cross sections are to be trusted, and they're all we got, the blade is the same thickness until very near the tip. This makes my job easier, but it will also make it a heavy and awkward weapon. All I could do about this is assume the taper starts immediately after the second blade section. This ensured I could remove the maximum amount of material from the pointy end while matching the available information. So I was a dumbass and went too deep with the angle grinder. This time I used the belt sander because it takes off the material slower. Here I get stung by a wasp and decide it's close enough. Before grinding in the bevels, I had to mark out the center line on both the faces and the edges of the blade. I used a transfer punch the same diameter as the thickness of the stock to describe a perfect center line. Next came hours of sweaty stock removal in the gross Virginia humidity. I've got a lot of this footage, so I'm going to take a minute to geek out on Iron Age metallurgy and craftsmanship. So far I haven't mentioned the alloy I'm using. It's just mild steel, A36, the kind you buy at the hardware store. If you know anything about swords, you know that's pretty much the worst steel you could use. The carbon content isn't high enough to heat treat, so it won't hold an edge, and if you bend it, it stays bent. Shitty sword, right? Well, I've done my research, and I've got an elaborate justification for this. Some of the earliest iron swords in Europe were produced with the techniques we expect to find in a good weapon. That is, the cores are some kind of softer iron, great for shock absorption, and the edges are higher carbon steel that can be hardened by quenching. This is a good way to make use of the rather difficult to control bloomery process, which for any number of reasons did not produce as much carburized iron, what we would call steel, as just iron. By the time we get to the 2nd century BC, when the original sword was produced, people had been making quality weapons like this for centuries. However, there was a paper looking into the properties of our sword that showed it was not one of these quality weapons. The carbon content was low, roughly the same as A36 or lower depending on where they looked. And since the iron was produced by the bloomery process, it was full of slag inclusions that only made it weaker. They also performed some hardness testing using the Vickers scale. Just for reference, my hardware store A36 is supposed to be about 130 on the Vickers scale. You know what the average was on the edge of the original? Fucking 87. So why would I pay for tool steel when the cheapest, worst possible steel available today is already going to be better than the original turd of a blade? Now it's interesting that even over 2,000 years ago, this was a bad sword. The Romans liked to talk like they had better weapons than their enemies, like the Celts, who supposedly had to straighten bent swords mid-battle. But the reality is anyone in the continent at the time could and did make decent heat-treated blades. There was always a broad range of quality though, and in times when lots of weapons are required all of a sudden, you're going to get a lot more Harbor Freight level stuff. This is one of the theories put forth in this paper addressing why this sword and many of its associated finds were such garbage. After roughing in the bevels, I went back and forth between a handheld belt sander and a smaller grinder to get closer to the final thickness. I wish I had been this systematic with my grinding earlier. I had no strategy at first, and it took way longer. I had to go back and get the tang and lower part of the blade closer to the original. The rounded corners were a defining characteristic of this blade type. Later ones would be more square, meant to butt up against the handguard rather than get set into it. The first file I tried was clogging up and gouging the surface by dragging long shavings. This one, with much fewer teeth, cut like butter. Still, it took a while to get everything flat, and I'm not really looking forward to filing proper carbon steel when I try forging another sword. The ridge looked a little wavy when I looked down the blade, so I marked out the problem areas and filed until the ink went away. I did the same thing on the edge to smooth out high spots and flats. I started out with 120 grit sandpaper. Later I brought it up to 220, maybe 320. I didn't film that. I think that would have been just fine for this cheap sword back in the day. There was no sandpaper, so to get this finish they would be using abrasive stones. To get it much shinier, they would be rubbing it with leather and ground pumice or something. And as I discussed earlier, I doubt they would have bothered on this one. After that, I filed in the micro bevel that will be the actual cutting edge of the sword. I want to note that I never put in the effort to get the fit and finish to the standards of an expensive reproduction. The original sword was trash quality and it was not unusual. The line drawings clearly indicate it was not symmetrical and the metal itself was soft and unrefined, so I doubt whoever made it bothered to make a highly refined hilt. In fact, I'm of the opinion that most good reproductions of Roman swords are too good to be realistic. For example, I've seen several modeled after this particular sword. They are at or under 2 pounds, and must be including the sort of distal taper you expect from a more sophisticated blade. My sword, made from the best information available, is a fairly constant thickness and is struggling to stay under 3 pounds. It's worth mentioning here that there is no significant difference in density between modern carbon steels and ancient bloomery iron. When people pay good money for a replica item, they expect high quality, but quality today is different than 2,000 years ago. Machinery allows incredible precision and repeatability, and the fact that most things are made by machines today raises expectations for even handmade items. 2,000 years ago, everything was made by hand, and swords were not displayed so much as used for killing. Minor symmetry issues, a slight wave in the blade, and even the odd tool mark would be considered unacceptable today. But it's easy to find these sorts of imperfections in all artifacts from the time period. What we would today call high quality does not necessarily mean realistic. After all, doubling the time investment to bring a sword to industrial age aesthetic standards with Iron Age tools would not make it stab any better. Now that said, I'm not just making excuses for not trying very hard, I am trying to come up with a plausible reconstruction. That's why I went with a turned handle. If our sword was cheap and produced quickly with a shitload of others, it would have made sense to turn the pommel and handle on a lathe. Someone who knew what they were doing could probably crank one of these hilts out every 10 minutes. I do not know what I'm doing, however, and the fact that I took the time to build a lathe, sharpen old tools, and figure out how to use them should prove I'm not just being lazy. There isn't much evidence for what the hilts would have looked like at this period. That's why I've got one of these. Actually, I have 30, because that was the minimum order. You'll be hearing that joke again in future videos since I spent money on it. Anyway, there isn't nothing to go on here. The fact that excavated swords of this type never have hilt parts, with only 2 exceptions that I know of, means that the majority were probably wood. As far as the shape goes, I looked at Spanish and italic hilts from earlier times, both of which would have been likely design influences. Both could have a ridge in the middle, so I included it. I chose to make the pommel a ball because it works with the lathe and it turns up in later swords as well. Naturally, the hole didn't come out on the other side in the middle, so I had to open it up until it was centered. If I was thinking, I would have drilled the hole first and then used it as the lathe centers. tried this a couple of times with scraps before using the real handle. Turns out you gotta push pretty hard. Okay. Go, 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 go. Alright. Woo! Just to make sure it didn't keep smoldering and mess up the fit, I doused the inside with water. Perfectly round grips are bad for feeling which way your blade is oriented, so I filed in flats on either side. Here's where that lazy fit and finish comes in. Although if I was really lazy, I would use epoxy, which the Romans definitely didn't have. This hilt fitment was all mechanical. Whether or not the handle parts end up wiggling depends largely on getting the grip to butt up squarely against the guard. If they meet at an angle, the imperfect fit will allow room to move and it will just get progressively worse. This washer has a nice satin finish. Too nice. A bit of roughing up makes it look more like it was forged to cap the pommel. Now I know this is bad steel, but I just had to test it out on this mustachioed barbarian. So there are two major techniques of sword use, slashy and stabby, or cutting and thrusting if you're academic and boring. The Romans trained mostly in a stabby fashion.
No, don't let it fall!
Of course they slashed when convenient as well, but to be honest I didn't try very hard to get the edges consistently sharp. No, I think I just broke it. This is the first historical reproduction I've done on the channel, but I'm an ancient Rome nerd, so I have plenty of other plans. First should be a scabbard. Will that actually be the first thing I do next? Can't guarantee that. Guess you'll have to subscribe. Also watch some of my other videos. Anything but the welding table one. It literally has 40 times the views of the next most popular, and I think the others are feeling left out. Tell the devil who sent you.